if you have a calculator, you can figure out quite easily what quadrant an angle ends in. So for example, if I have 4,300 degrees, and I want to figure out what quadrant it's in, I could divide by 360, because 360 is once around. This gives me 11.94, which means it's 11 full revolutions. And then the 0.94 is almost another full one. So if you think about the four quadrants, does it make sense that this would be a quarter of the way around, or 25%? 50%, 75%. So the 0.94 is almost, it's over 75%. It will end in quadrant 4. But most of these are going to be non-calculator. So if I had something like 4,300, and I didn't have a calculator, do you remember that you could add or subtract 360 degrees and end with something that's coterminal? So if I found what was coterminal with it in the first time around, it would be easy to tell what quadrant it's in. Now for mental math purposes, I probably wouldn't just start with subtracting 360. I think it's easy if I took 10 of them off right away. Right? That would leave me with 700 degrees. If I took off another 360 after that, I get 340 degrees. So 4,300 degrees is coterminal with 340. That's very squeaky. And then if you knew it was coterminal with 340 degrees, it would also be easy to tell it's in quadrant 4. But since this is grade 12, we will more often be doing questions in radians, and they will almost always be without calculator. And almost always we will get a radians question that involves pi. So we're going to look at some of the shortcuts for figuring out pi. Again, if you had your calculator, you could just take this and divide by 2 pi to see how many rotations, but it will be a non-calculator question. So the strategy that I'm going to teach you, which I think is fairly easy to do, is if you take a fraction, like negative 23 pi over 6, and you change it to a mixed fraction. Can you see that 23 over 6 is negative 3 and 5/6? But now the negative 3 isn't full revolutions, because if you think about pi, pi is only halfway around. All the way around would be 2 pi. And so in this situation, if I have negative 3, negative 1 would be going in this direction to pi, this would be negative 2 pi, and this would be negative 3 pi. So negative 3 pi will end on the negative x-axis, and since 5/6 is more than half, it's going to end in quadrant 1. One of the things that's going to be really nice with radians is that you will be able to tell the reference angle very quickly. The reference angle in this case is pi over 6. So if you have pi over 6 in your fraction and it doesn't reduce to a smaller fraction, that's going to be your reference angle. So we could say that negative 23 pi over 6 is coterminal with pi over 6. You want to do another one just for practice? Let's say I have No. Let's do 26 pi over 3. Makes sense that 26 pi over 3 is the same as 8 and 2/3. And so if you're thinking, I hope you're starting to see a pattern after I write a couple of these. This would be 3 pi, then this would be 4 pi. And I could keep writing, but can you tell me, is 8 pi going to end on this side or on this side? On the right-hand side. How come?
Okay, I can't really say it.
Say it in German.
What?
Because, say the word in German.
Gerade, like
Okay.
0 to, when.
They're even numbers.
Even.
Yes.
What's the opposite?
Odd.
Odd, okay, good.
So the odd numbers are here, the even numbers are here, so the fact that we have 8 pi will end up here. 2/3 is more than half, and since we're going in the positive direction, right, it's not 8 times around, just have to use your imagination. But it will end in quadrant 2. So we can say that 26 pi over 3 is coterminal, isn't it, with 2 pi over 3. And its reference angle is pi over 3.
Isn't that wrong? I mean, we have 2. No, wait, you're right, yeah. It's like half. One thing is half.
I'm a little nervous.
Okay, wait.
I mean, I didn't draw
It
8.
should be a little bit more to the top.
Oh, like where I drew it? It's
Yeah.
not to scale.
Yeah, no, before that F-file would be something like that direction.
So our first practice with this, we have to be able to quickly determine what something is coterminal with in radians and in degrees. So I have a sheet to practice. We'll do some of these together. Oh, I did. Somebody else just the other could be in your. Okay. Did I send too many down any rows? You good? Extra? You good? No, that makes sense. Okay, so there's 2 assignments, and we can do them actually at the same time. So assignment 1 says, locate the angles, ignore sine and cos, stating your answer in terms of angles that fall in the first positive revolution of the unit circle. This basically means find the first positive coterminal angle. Then assignment 2, once you know that positive coterminal angle, for questions 1 to 8, can you write the coordinates? And 9 to 32 actually solve what they're saying. So when we look at this, if we start with question 1, we can say 13 pi over 6 is coterminal with, and then when trying to figure out what it's coterminal with, you could take your 13 pi over 6, change it to a mixed fraction, and you will get 2 1/6 pi. And you see that that's in quadrant 1. because 2 pi would end at the positive x-axis, and 1/6 is less than half, it's going to end in quadrant 1. So we can say that 13 pi over 6 is coterminal with pi over 6. Then assignment 2 says, what is the coordinates at pi over 6? From your unit circle, the coordinates are root 3 over 2, 1/2. So we're going to use this to figure out questions like, what is sine of 13 pi over 6? Mental math, you'd say, well, 13 pi over 6 ends in the same place as pi over 6. So I know that sine of pi over 6 is the y-coordinate, which is 1/2. So I would know sine of 13 pi over 6 is 1/2. Question number 2. We took 19 pi over 6. It's coterminal with, well, 19 is 3 and 1/6 pi. And you see that that ends in quadrant 3. Because 3 would be on the odd side, and 1/6 is less than half. It's going to end in quadrant 3. So what's your pi over 6 family member in quadrant 3? 7 pi over 6. So 19 pi over 6 ends in the same spot as 7 pi over 6.
Sorry, I was having a meeting with Valentine about student council.
Okay. I'll change the attendance. Remind me at the end. Well, let's do one more. If you had 19 pi over 4, it would be coterminal with, well, 19 pi over 4 is 4 3/4 pi. That's going to end in quadrant 2. So what's our quadrant 2 pi over 4 family? 3 pi over 4. And if you wrote the coordinates, oh, I didn't do the coordinates for the last one. So in quadrant 3, 7 pi over 6 will be negative root 3 over 2, negative 1/2. If I had quadrant 2 for 3 pi over 4, my coordinates would be negative root 2 over 2, root 2 over 2. So for the first 8, you write the coordinates, and then after, in question 9, actually figure out what sign. Do you need to do that?
Yes, and also, did we do a unit circle quiz?
No, that's tomorrow.
Okay. Oh, I'm gonna not really quick.
Yes. Are we okay with the coterminal angles? So we need to figure out what quadrant it's in, and then you can find out what's coterminal quick. No, this is just for you to practice. You have your unit circle quiz tomorrow. You're making your pie plate for after the weekend. And now we're ready to do mental math. Basically, for the mental math of your unit circle, you really only need to know quadrant 1. And then after you have quadrant 1, your cast rule will figure everything else out. Okay? So, for example, if I see sine of 7 pi over 6, a couple of things I would do. I would say I recognize it's part of the pi over 6 family. So in quadrant 1, sine of pi over 6 is 1/2. So I know this is also going to be 1/2. I just have to decide if it's going to be positive or negative. But because 7 pi over 6 is in quadrant 3, has to be negative in quadrant 3. So then I would know that sine of 7 pi over 6 is negative a half. Now if you have your complete unit circle, you could just go to 7 pi over 6 and look at the y-coordinate, and it would show up as negative a half that way as well. Okay, but the idea is we're going to think about the family, and the family is basically your reference angle. And we're going to think about the quadrant, and the quadrant is going to tell us if it's positive or negative. So tangent of 2 pi over 3. Oh, another thing that I use for remembering tangents, I remember that pi over 6 family is root 3 over 3, because 3 plus 3 equals 6. That's just a memorization thing that works for me. And tan of pi over 3 is just root 3, because 3 is 3. It helps me remember it quicker than having to draw out the special triangles and figure it out. Or do sine divided by cos and figure out the fraction. So here, tan of 2 pi over 3, I know that my family is the pi over 3 family, so I know it's going to equal root 3. Then I think about what quadrant it's in. It's in quadrant 2. And my cast rule would say tan should be negative in quadrant 2. So then I'll get negative root 3. Of course, if you have your pi plate, you could go to your pi plate and just look. All right, here is 2 pi over 3, and I have negative root 3 written down. Cos of 7 pi over 4. I would think about my pi over 4 family, and cos of pi over 4 is root 2 over 2. Then I would think about, so my family, pi over 4. Then I would think about which quadrant 7 pi over 4 is in. I don't have to write that plus sign there, but it's just telling me that I thought about quadrant 4 cos is positive. And then we get into the reciprocal ones. So if they ask you for secant, cotangent, or cosecant, off to the side, you can start by thinking about the one it's related to. And notice you never change the angle. So if I want to find secant of negative pi over 4, off to the side I'm going to find cos of negative pi over 4. It's part of my pi over 4 family, so I know it's going to be root 2 over 2. It's in quadrant 4, so I know it's going to be positive. Do you remember when we did the special triangle that we originally had written it as 1 over root 2? Okay? So if you had cos of negative pi over 4, you're allowed to write it either as root 2 over 2 or as 1 over root 2. When you do secant of negative pi over 4, you can either write it as the flip of root 2 over 2 or the flip of just 1 over root 2, which is just root 2, but you can write it as root 2 over 1. Okay, if it's multiple choice, they'll always have the denominator, well, most of the time they'll have the denominator rationalized. Yes?
But we know what quadrant?
Yeah, we know that it's in quadrant 4. Because negative means you're going the opposite direction. And if you just go pi over 4,
Oh, okay.
yeah, it'll be in quadrant 4. So cotangent's negative 11 pi over 6. I would think about tangent of negative 11 pi over 6. Obviously, it's part of your pi over 6 family. I already know It's root 3 over 3. You like that 6? 2 3s add up. Okay. What quadrant is it in? It's going to be in quadrant 1. If 11 pi over 6 is in the 4th quadrant going in the positive direction, does it make sense that if you went negative 11 pi over 6, you would go 4 quadrants in the negative direction, which would end in quadrant 1? So it's going to be positive, right? And it could have been written as 1 over root 3. Remember that from our special triangles as well. So you could write this one either as 3 over root 3 or just root 3 over 1. Cosecant, we would think about sine. And when you have an axis family, so negative pi over 2 is axis family there, you don't have to think about what quadrant because an axis family is kind of in between quadrants. Negative pi over 2 is right at the bottom. Sine is which coordinate, x or y? The y coordinate. So at this point, my y coordinate is negative 1. So then cosecant will be 1 over negative 1, which is obviously still just negative 1. So we did all of these questions individually, and the exam likes to combine them like this, where they put 3 of these questions all together in one, and you have to do some math to go with it. I'm going to color code this question. I'm going to figure out secant in blue. Then I'm going to do the cos one in green. And finally, the tan one in purple. I'm just going to put answers in there. I'm going to do my work off to the side. When these are marked, they just look at each of your answers, and they check if your fraction is right, and your sign is right, positive or negative. And you'll get, this would be a 3-mark question on the exam. You would get 1 mark for each of the things in the blue, the green, and the purple brackets. So, starting with blue, I want to find secant of 11 pi over 3. So I would first figure out cos of 11 pi over 3. I know that my reference angle is pi over 3. And so from my unit circle, I know that cos of pi over 3 is a half. So I know this is a half. I just have to decide if it's positive or if it's negative. A little memorization strategy that works well for me, for doing these in my head, I memorized one of them really well. The one that I've memorized really well is that sine of pi over 6 is a half. So when I get to the pi over 3 with cos, I'm like, oh, well, cos of pi over 6 can't be a half because sine of pi over 6 is a half. Therefore, cos of pi over 3 is a half. So just knowing one well, you can sort of double check the other ones. So if I know sine of pi over 6 is a half, then I know cos of pi over 6 isn't a half. Which means that sine of pi over 3 can't be a half, which means cos of pi over 3 has to be the half. 11 pi over 3 as a mixed fraction is 3 2/3 pi. Do the mental math, what quadrant will that be in? Right? 3 means that you're going to be on this axis. 2/3 is more than half, and since it's a positive angle, you would be going counterclockwise. going to be in quadrant 4. So this is going to be positive, which makes secant 2 over 1. And I can write that in first. Next, cos of negative 5 pi over 4. Well, I know it's part of my pi over 4 family, so I know it's root 2 over 2. If 5 pi over 4 in the positive direction is quadrant 3, then 5 pi over 4 in the negative direction will be quadrant 2. And so we'll have a negative there. We'll have negative root 2 over 2. And finally in purple, tan of 23 pi over 6. It's part of my pi over 6 family, so I know it's going to be root 3 over 3. And 23 pi over 6 is 3 and 5/6 pi. It's quadrant 4, so it's going to be negative. So I fill this in as negative root 3 over 3. So you would get 1 mark for the blue brackets, 1 mark for the green brackets, 1 mark for the purple brackets. And this question would be out of 3. So you get 3 out of 3. Then if you decided not to do anything else, you would get an E1 error for not writing the final answer and lose a half mark. Or if you made mental math errors from right now, you would get a half mark for screwing up. So you've got full marks now, but we still have to simplify. And you see that these 2's would simplify to 1 over 1. And the negative times the negative, that'll be positive. Root 2 times root 3 is root 6. 1 times 3. There's the final answer. Root 6 over 3. So these questions, which are unit circle questions that have 3 unit circle questions sort of combined into one, I kind of know why. Traditionally, they're not done very well on the exam because you have to do a lot of work. You have to know your cast rule, coterminal angles, have your unit circle memorized. There's lots of places where you can make small errors. But if you just figure out each one separately and then put it together, you'll be fine. And they're really good for practicing your unit circle. So you're gonna have your unit circle memorized for tomorrow. When you are doing questions like this, my suggestion is try to do the value first in your head, then double check on your unit circle that you've got it right. Because you'll need to have this memorized again for this test. On your next test, I'll let you use your pie plate. But on the exam, you have to have it memorized again. And for AP Calculus, you have to have it memorized again. So we have to get these values, so may as well practice already how you're going to remember. And the best way to practice is to do questions like this. So I have another handout. In particular, on this handout, there's 4 parts on this handout. Parts 3 and 4.
We're missing one there.
Here's the one. Parts 3 and 4 are really good at practicing. And we're going to do one of them. I'm going to pick part 4A together. So you get a start. And the reason I wanted to do part 4A is it has some squares in it. And once again, I'm going to color code. Now, what does a square do? It just means the same thing twice. Like cos squared of 3 pi over 4, you could write cos 3 pi over 4 times cos 3 pi over 4, because squaring means repeated multiplication. So whatever I find for the blue one, it's going to be squared. Same thing for the green one, whatever I find for tan, it's going to be squared. And whatever I find for secant, it's going to be squared. Okay. 3 pi over 4 is part of my pi over 4 family. You can use scrap paper if you need to write it down, but I'll go through some of it in my head. I see the pi over 4 family. I know it's going to be root 2 over 2. 3 pi over 4 is in quadrant 2. Cos is negative in quadrant 2. What's going to happen when I square that negative? It's going to become positive. If you forget the negative, though, inside the bracket, on the exam they take off a half a mark for not having the negative. Even though the answer comes out the same, you have to show that you know where things are positive and negative. Tangent, negative pi over 3. Okay, I know that tangent's going to be root 3. Can you see that negative pi over 3 is in quadrant 4? And tangent is negative in quadrant 4. And finally in purple, I know that cos of pi over 6 is root 3 over 2. So secant will be 2 over root 3. Negative 7 pi over 6 is in quadrant 2. Cos is negative in quadrant 2. So secant will be negative in quadrant 2. So in the previous example, I showed all of that work on the side of what I had to do. This one I did more mental math. Okay? So if you do want to do some work, you can do it off on the side. But when we write things down, we just write the values that they're equal to. And now we can simplify. Again, this squared is going to be positive 2 over 4 when we square it. This one now is positive 3. And this one's going to be positive 4/3. So this is basically 3 halves. 1/2 times 3, 3 halves, plus 4/3. I need a common denominator. I'll make it, this will be 9/6. 17 over 6. And the nice thing is, when you get there, you can check your answer and see if you're right or wrong. Then I get nervous because I'm like, oh, I probably made a mental math error. But it was the same, so it's good. So I wanted to show you the squared part because that sometimes throws people off. The easiest question in part 3 and 4 is 3b if you see the shortcut. you see the shortcut in 3D? It's one of our big ideas. If you have sine squared theta plus cos squared theta and the thetas are the same, which they're both pi over 4 in this case, it's just equal to 1. Next, we work backwards and we find angles. Yes?
Did we get like assigned or do anything before I came?
No. While we did some of this notes, we talked about strategies for memorizing the units. So you've had this question before in grade 11. In grade 11, you would have got this question, but instead of 0 to 2 pi, you'd have 0 to 360 degrees. And in grade 11, you would use your calculator to find your reference angle. The difference in grade 12 is if this value is on your pi plate, then you don't need a calculator. So sine is your y-coordinate. You have to ask yourself, is your y-coordinate ever root 3 over 2? And the answer is yes. What family is that? So think in quadrant 1, what family is that? And here's, again, if I've memorized that sine of pi over 6 is a half, I've got root 3 over 2, it's not pi over 6, it's going to be pi over 3. Then if we think about our cast rule, if sine is negative, it has to be in quadrants 3 or 4. And so we can right away say, well, what is my pi over 3 family in quadrant 3? That's 4 pi over 3. What's my pi over 3 family in quadrant 4? That's 5 pi over 3. And then we've got it set up. And that's all we'd have to do on non-calculator if it's on our pi plate. Is -1 ever your x-coordinate? That's an axis family, right? Axis family, you can just go right to the answer. What angle is it? Pi. 180 degrees, but this question, the domain of the question will tell you whether you're working in radians or degrees. So you just have to write pi. Sometimes you might have to do a little bit of work. Tan of theta is -1. Is tan ever 1 on your pi plate? And if you think about quadrant 1, that'll tell you the family. Family is pi over 4. Where would we be looking? In quadrant 2 or in quadrant 4? So then what's my pi over 4 in quadrant 2? 3 pi over 4. What's my pi over 4 in quadrant 4? 7 pi over 4. Anytime you get one of the reciprocal ones, first step, if secant theta is 2, well then cos of theta is 1 over 2. These are identical. But now we can use our pi plate. What family gives us 1/2 for cos? Again, since I've memorized that sine of pi over 6 is 1/2, I'll know my reference angle here has to be pi over 3. And since it's positive, it's going to be in quadrant 1 4. Yeah? Good. Okay, it's 5 o'clock. It's 5 o'clock. There we go. Grade 9. Sometimes you have to do a little work, like this one. Are you okay if I move the 1 over and divide by 2 all in one step? Is that okay? What family gives sine as 1/2? 5 or 6. Then, which quadrants should it be in? Quadrant 3 and quadrant 4. So we use the cast rule. We need to know our first quadrant, and then we can do all of this mental math and solve them quickly. Now, before we get to this one, I'm going to add an E. You could still have ones, though, that are not on your pie plate. And you would still have to do them like you did them in grade 11, except now you're in radians. So I'll just review what would happen if you got a question that start off with this, 3 tan theta plus 4 equals 0. I get tan theta by itself, and I get negative 4/3. Is negative 4/3 ever a tan value? No. So now we have to use our calculator. So what do we do first? We find our reference angle. When using your calculator to find your reference angle, remember reference angles are based on actual triangles with all positive values. So even though tan of theta is negative 4/3, when you find your reference angle, you will always use positive values. This will ensure that when I do tan inverse, I get a positive answer. So I go tan inverse of 4 divided by 3, 0.927. And I'm just going to put dot, dot, dot here to say I'm not rounding yet. I'm going to use all of my decimal places. Now, according to the cast rule, if tan is negative, it's either in quadrant 2 or quadrant 4. A nice trick with your calculator that you can use is above the on button is the store button. And I like to store answers, and I often use X right beside the alpha button, just because it's the easiest letter to pick. You can hit alpha A, alpha B, alpha C, store it as any letter you want. But now, whenever I type X, it types in that whole number for me, plus 16 other digits or something that it's memorized. So if I want to find my answer in quadrant 2, I would go pi minus my reference angle, and I get 2.214. So early on, you might actually like to draw these out and think from 0 to 2 pi, this one would equal pi minus my reference angle, and then this one would be 2 pi minus my reference angle. And the nice thing about storing that as x is now I can just go 2 pi minus x, 5.356. and we have our final answers. So we can still get calculator questions. In fact, on the calculator section of the exam, they like to sometimes mix it together, where part of it is calculator and part of it's non-calculator. And then they start mixing in other things you've done before. Yay, just to complicate it a little bit more. We can now solve questions that are quadratic, but quadratic with trig functions. So you have to remember how you solve quadratic equations with factoring, but now you also have your unit circle involved with it. So if this was a quadratic equation and I had x's instead of cos's, do you remember how you would solve a question like this? Right? We would factor. We would make one side equals 0, and the reason we factor is factor changes something from adding and subtracting to multiplying. And this is so powerful because if you have two things that multiply and the answer is 0, one of those two things has to be 0, right? If this, here's the time sign right there, if this times this is 0, well, that means either the x has to be 0, it wouldn't matter what that is, or the x has to be 1, because then it wouldn't matter what that is. And you will get 0 as your answer. So now that we have trigonometry, it's the same thing. I have a cos theta in common. If I factor it out, I'd be left with cos theta minus 1, which means either this cos theta is equal to 0, or this cos theta is equal to 1. Is cos theta ever 0? Yes, that's axis family. When does that happen? It's your x-coordinate. So it happens here, right? No, it happens here, and it happens here. So at pi over 2 and 3 pi over 2. Is your x-coordinate ever 1? Well, that's an axis family as well. This time it's right here. That's at 0 and also 2 pi. Okay? But the textbooks sometimes, you have to be careful. So when you're done a question, you should always double check your domain. So my domain says solve for theta between 0 and 2 pi. 0's included and 2 pi's included. So you would have to have both of these answers to get the question right. The textbook sometimes does this. Notice the difference? There's just a tiny line missing. If you answered this, and this was given, I'd have to take off a half mark because you included 2 pi, and 2 pi is not included this time.
Anything less than 2 pi is included?
Okay. So,
Isn't pi itself also an answer?
well, if I go to pi though, then my x-coordinate is negative 1.
Okay.
Right, so it'd just be 0 and 2 pi in this situation.
Let's say it is like that and you were to give it to us on a test. Would you want us to write 2 pi and cross it out?
You could,
You don't have to do that.
you don't have to, but if it was written like this, and you're like, because for me typically, you're going to find that most of these questions are between 0 and 2 pi, and including everything. And even the ones that aren't, it's usually helpful to just first figure out everything between 0 and 2 pi. So if I gave you this and you wrote this, you could just go, oh, I can just X that one out, I went too far.
I mean, yeah, the better question would be, what would the exam want us to do?
In this case, either would be fine,
Alright.
okay? But the exam, in some situations, if there's an answer that comes up that shouldn't be an answer, they want you to show it and X it out. Okay? Right, like a non-permissible value shows up as an answer, but then you find it later and you take it out. You need to show it and cancel it out. Here, we don't have to show every answer and cancel it out. Because technically, isn't 4 pi technically end here? So it would possibly be another answer, but we would have to cancel it out. And then I could have 6 pi, because it ends here. But then I'd have to cancel it out. So, no, we don't have to, there would be an infinite number of coterminal angles that end here, which kind of leads into our next chapter. We change this to be all answers, and you have infinite amount of answers for all of these questions. But we're getting there. We're not there yet. Okay, I think we have time for one more. Sine squared theta minus 3/4 equals 0. This would be a non-calculator question on the test. Algebraically, if you're ever unsure how you would do a trig, you could ask yourself, how would I do it if it was just an x? Would you factor this one, or would you just get the x squared by itself? Yeah, probably get the x squared by itself. So I'm not going to solve that. I'm just, now that I have the idea from there, I'd be like, oh, well, I'm going to get the sine squared by itself. And then how do I get rid of something squared? Square root. And I'd square root that side. And I would have lost a half a mark at this moment.
Plus minus.
Because I didn't do the plus and minus. Oh my god. Would you forget the loop?
Absolutely, every goddamn time.
No, you have to remember.
Yeah.
This one actually costs you more than a half a mark.
Oh.
It's going to, I'll show you why. It's going to be more catastrophic in the end. You lose a whole mark.
Is it
Okay.
multiple either or
Now.
something?
Is the square root of 3/4 on your pie plate?
No, the square root 3, I guess comma over 4 would be on there.
So, not exactly, but yes, because you can simplify this, right? Because a square root of a fraction, this is the same as plus or minus the square root of 3 over the square root of 4, which just becomes 2. And that is on our pie plate. What family is it? Not pi over 6, it's pi over 3. And then, because of the plus or minus, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. 4 answers. Each of those answers are given a half a mark. Can you see if you forget the plus or minus, you would be missing 2 of them. And then you would lose a whole mark as a result. This is like a family gathering, the whole pi over 3 family solution. Right? All right.